Okay, so we'll continue where we stopped yesterday. I'll just take one step back, just go over some of the key features of MPC, and then we will talk about the course plan and what we are going to do in the next couple of days. Okay, so what we talked about, the popularity of MPC, it's because it is a computer based approach, and as I mentioned, model predictive control. So it's a model based, we use models to predict the behavior in the future, and then we use an optimization, some kind of an optimization to figure out what's the best manipulated input moves in the future, implement the current input move at this time, and repeat the entire process all over again. Okay. So that is the way the MPC is going to work, and then we mentioned yesterday that the key features of MPC is its ability to handle constraints. This is something that we will come to probably in week 3, week 4 of this course. That is when I first talk about the industrial MPC algorithm, and we said that it is a naturally MIMO system. So we do not talk about first CISO system and then extension to MIMO system. As I said, MIMO system, a CISO system is nothing but a MIMO system with one input, one output. Okay. And we talked about the receding horizon approach, and we took an example of you driving a car. You are trying to overtake a vehicle in front of you, and let us say that the vehicle is going at a particular speed, and then based on that you determine how you are going to overtake that vehicle, and as you are overtaking the vehicle increases its speed. Okay. Yesterday after the class there was a question that are we replacing sensors with an observer? Okay. We are not replacing sensors with an observer. What is happening is, let us say you are right now, you are over here, and this is where the truck is. Okay. So your sensors are your eyes. You are going to look at the truck's position. Okay. But truck's position itself is not sufficient for you to take decisions in an optimal manner. What you also need is the speed, and what you also need is the rate of change of that speed. But you are not really measuring the speed, you are not really measuring the acceleration. What you are really measuring is position. Right now the position is so and so, a second back the position was so and so, a second back the position was so, and so on. So you have the position of this particular vehicle for maybe last minute or last half a minute. Okay. That is when you said, that is when the vehicle came into your view, and you had this idea that you need to understand how that vehicle, how that truck is moving. Okay. So from these measurements you are inferring something. Okay. And that is what an observer does. Okay. Your traditional control was basically about the location, about the history, and you are integrating over the error in some way. So there was no this kind of a behavior at all involved in your PID control or your on off control or your ratio controls and things like that. This is something unique to MPC, where you are predicting the behavior, and in order to predict the behavior you do not only need the sensor information, but you need the information of the entire state. So course outline, this week we are going to really go over the basics of control, basics of linear algebra, and so on. Okay. Then the next 4 weeks, that is up to your quiz 1, from week 1, week 2, week 3 and week 4 we will do introduction to MPC. We will talk about models. Previous slide I talked about the model choices. We will talk about models interconversion. We will talk about something about the model analysis. You are used to transfer function models in time domain, which is 1 divided by tau s plus 1 type of models. How do you convert it into discrete time is something that we will also talk about in week 2. Week 3 we will talk about first principles models and interconversion. Week 4 we will talk about dynamic matrix control, that is the industrial algorithm that I mentioned. Okay. So if you see, the red talks about models, the blue talks about the control algorithm, and the orange color over here talks about the estimation part. Okay. So, in each 4-week component, I try to cover the modeling aspect, I try to cover the control aspect, I try to cover estimation aspect, because all three of them are integral to using an MPC controller. Okay. So, first 3 weeks or first 2 weeks are more like recap or laying the foundations. Next 2 weeks are about MPC in the industrial context. Next 4 weeks are going to talk about MPC and its relation with the more traditional linear quadratic optimal control. Okay. Those theories were developed in 1960s and so on, and how does MPC relate to that is something that I will talk about. And the last 4 weeks we are going to cover some of the more practical aspects of implementing an MPC controller. Okay. So, first 4 weeks laying the foundation and industrial MPC, next 4 weeks its relation with linear optimal control including linear optimal estimation, and the last 4 weeks some of the practical aspects of MPC. So, what are we going to do in this particular week in the next couple of lectures? We are going to talk about linear controllers, and why we are talking about linear controllers is because linear controllers are most commonly used as I had mentioned in yesterday's class. The other thing we are going to really focus on is discrete time linear models. Okay. Now, the discrete time linear model, this is an example of state space model, this is an example of a transfer function model, okay, and this is an example of step or impulse response models. So, we are going to talk about all of these 3 models in the next week. This week we are going to recap basics of linear algebra and process control or your first course in control in the way that it is relevant to this particular course. Okay. So, that all of us talk kind of the same language because some of you are aerospace engineers, some of you are electrical engineers, applied mech. So, you would have learned the same concept in slightly different languages. So, to make sure that we talk a similar language, we will do this. Okay. So, with respect to this, first we will do a brief recap of undergraduate control concepts of feedback, feed forward, block diagram, transfer functions, PID control, and then we will do a recap of basic linear algebra and basic modeling concepts. Okay. Again, there was a question, I am not a chemical engineer, would that matter? No, it would not matter, because we will take examples motivated from chemical engineering, but what you are really going to work on are models of this nature. Okay. So, it really does not matter where those models came from, as long as we have those models, we are going to be able to do this control. Okay. So, only the problem definition would have relation to chemical engineering. Beyond that, so 95% of the things that we are going to do is going to be applicable to chemical, electrical, aerospace or any other engineers for that matter. Okay. So, what is the plan for the next couple of days? We will control the basics of we will cover the basics of process control, we will do a recap of linear algebra, we will talk about differential equations and difference equations. So, difference equation is of this form. So, even if you have we will go over this in detail. Transfer functions, we are not really going to go in detail. We are going to cover transfer functions insofar as it is important for you to convert a given transfer function model into a state space model. So, all of this we are going to talk really based on the state space model form and the step response model forms. Okay. So, the relation between ODE model and difference model is quickly something that we will talk about, and finally we will do the introduction to MATLAB. Okay. So, each of this probably each concept is going to take about half an hour to cover each of these concepts. Okay, that's the plan for the next 2 lectures. Any questions so far before we move further?